Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss molecularity of a reaction. Last class I have discussed order of a reaction. I have also given idea about molecularity in the last class. Now I will give some examples, then you can understand better. Molecularity, already I have given idea that it is the total number of molecules taking part in a balanced equation of elemental reaction. Correct? In any elemental reaction, what is the total number of molecules taking part in the reaction? That number is called molecularity. Okay, this is actually property of a reaction called molecularity. It helps in understanding its mechanism. The number of reacting species which must collide simultaneously in order to bring about a chemical reaction is called molecularity of a reaction. Molecularity of a reaction. The reaction can be unimolecular when one reacting species is involved. For example, decomposition of ammonium nitrite. Ammonium nitrite. Okay. Here ammonium nitrite means NH4NO2. If it will decompose, it will give N2 plus 2H2O. Then here only one molecule is taking part in a reaction. That is called unimolecular reaction. Only one molecule. Bimolecular reaction. Bimolecular reaction involve simultaneous collision between two species. Okay. For example, dissociation of hydrogen iodide means 2Hi. 2Hi, it will give on collision H2 plus I2. 2Hi will give H2 plus I2. Here 2Hi, two molecules are taking part in the reaction. That's why it is called bimolecular reaction. If only one molecule is there, then that is called unimolecular. Unimolecular reaction. Okay. Like that way, trimolecule, also called termolecular reaction. Here three molecules will collide. Three molecules will collide. Okay. It involves simultaneous collision between three reacting species. For example, 2NO plus O2. It is giving 2NO2. Then in the first case, in the case of NH4NO2, it was unimolecular. Molecularity is equal to 1. In second case, when it was 2Hi, then molecularity is equal to 2. Now in this case, trimolecular or TER, termolecular reaction means 3. 2NO plus O2. 2NO2. Okay. 2NO2. Then here molecularity is equal to 3. Molecularity is equal to 3. The probability that more than 3 molecules can collide are this probability I am talking about. The probability that more than 3 molecules can collide and react simultaneously is very small. Means Trimolecularity means 3, that is molecularity is equal to 3, that is less. Okay, that is very small. Probability is small. Okay, because collision will be difficult. More than 3 means 4, that is very great difficult to collide, and when they will not collide, then there will be no reaction. Then probability that more than 3 molecules can collide and react simultaneously is very small. Hence, reaction with the molecularity 3 are very less, very rare you can tell, and slow to proceed. If it is 3, then reaction will be very slow, because collision is not easy. Collision is not easy to, all should collide to itself. But in that situation, if number will increase, then all can't collide to all. That's why the reaction will be slow. This reaction, which apparently seem to be a 10th order, means I am giving an example. First understand the example, then you will understand. If you can say one example is there, KCl3 potassium chlorate plus 6FeSO4, potassium chlorate plus 6FeSO4 plus 3H2SO4 means total 10. 1 KCl3, 6 FeSO4 and 3 H2SO4. Total number of molecules are 10, and it gives the product KCl plus 3 Fe2SO4 whole 3 plus 3H2O. It gives the product KCl plus 3 Fe2SO4 3 plus 3H2O. Then here total number of molecules taking part in the reaction is 10. 1 KCl3, 6 FeSO4, then 1 plus 6, 7 and 3 H2SO4. The reaction, I am talking about this reactor. This reaction, which apparently seems to be of 10th order, is actually a second order reaction. Second order reaction. Okay, but here number of molecules are 10, but molecularity how much? This reaction is of second order, finally second order, but molecularity, this shows that reaction takes place in several steps. Which step control the rate of overall reaction out of this? Which step? Many steps may be there. The question can be answered if we go through the mechanism of reaction. Means the step which is important, that is actually elemental step. If many steps are there. Okay. For this means I am talking about this chances to win the relay race. Chances to win the relay race competition by a team depend upon the slowest person in the team. Last class I have given example. Similarly, the overall rate of the reaction is controlled by the slowest step in a reaction, called the rate determining step. Slowest step is called the rate determining step. Now this I told about the rate determining step and molecularity. Okay, now you can I can give example, one more example. Decomposition of hydrogen peroxide. Decomposition of hydrogen peroxide, which is catalyzed by iodide ion in an alkaline medium. Then it gives 2H2O plus O2. The rate equation for this reaction, what will be the rate equation? Then rate is equal to, you are knowing, because it is the peroxide 2H2O, it is giving 2H2O plus O2 in presence of iodide ion and alkaline medium. Then rate will be what? Rate will be, because it is peroxide, then dH2O divided by dt is equal to K concentration of H2O2, and iodide ion is also important here. Iodide ion means rate is equal to, means differential rate minus dH2O2 divided by dt. That is equal to K into molar concentration of H2O2 into molar concentration of iodide. But in reaction, now you can see, only reaction is only decomposition of H2O2. In a balanced equation, you are seeing that 2H2O2 is giving 2H2O plus O2, but iodide is required here. Iodide is required, it is a catalyst, and solution must be alkaline. Then here, what you will find here? This reaction is a first order with respect to both peroxide and iodide ion, because both are necessary. Evidence suggests that this reaction takes place in two steps. First step, H2O2 plus I minus iodide ion, it will react and it will give H2O plus IO minus iodine oxide. And second step, H2O2 plus this IO minus, 1 minus, that will react and it will give H2O plus I minus plus O2. Means it is giving three product. H2O2 plus IO minus, it is giving H2O plus I minus plus O2. Then now if we will add both reaction, then iodide ion will cancel. Iodide ion will be cancelled. Okay. Then what will remain? Then what I told you, that 2H2O, it will give 2H2O plus O2. Okay, but this reaction goes in two steps. Both the steps are biomolecular elementary reaction. Both reactions are important, both steps, and both are biomolecular elementary reaction, means molecularity is equal to 2. A species IO1 minus iodide oxide, you can tell, is called as an intermediate, since it is formed during the course of the reaction, but not in the overall balanced equation, it is not seen. Then the first step being slow, is the rate determining step. Thus the rate of formation of intermediate will determine the rate of this reaction, because this step is slow. Correct? You can understand also like that. Last class I gave an example of production of a motorcycle. Correct? All parts must be ready, only then you can tell that a motorcycle is now, one motorcycle is produced. 100 parts were required and in one day, and but now 99 parts only was ready. One part after 3 days. Then production will be one motorcycle, that is 3 days. In 3 days one motorcycle, but 99, you can say, suppose 99 parts were required, it was ready in first day only. Then you have to wait for the last part also. It's like a examination. Suppose 3-hour exam is there, all a student went. Only one student was sitting exam and invigilator was waiting for him up to 3 hours. Correct? Then you can't exam this. He can't tell. Invigilator can't tell that you submit the booklet and go. Has to wait for 3 hours. Then like that way, that slowest step is the rate determining step. Okay. Then this I have told you molecularity and this order of reaction also measure, that is a measurement of order of reaction. Slowest step is the rate determining step. Okay. Thus from the discussion till now we conclude the these things. What we have discussed, we can conclude it. First conclusion, order of a reaction is an experimental quantity. It can be 0 and even a fraction, but molecularity cannot be 0 or non-zero. Correct? Cannot be 0 or non-integer, not non-zero, integer. Non-integer can't be. Always molecularity will be whole number. And second conclusion, order is applicable to elementary as well as complex reaction. Order is applicable to elementary as well as complex reactions, whereas molecularity is applicable only for elementary reaction. For example, you can say complex reaction. For complex reaction, molecularity has no meaning. Okay. For a complex reaction, molecularity has no meaning. Keep in mind. Okay. And what is the third conclusion? For complete reaction, order is given by the slowest step, and molecularity of the slowest step is the same as the order of the overall reaction. Now both will be the same in this case. Again I am telling slowest step and means this for complex reaction I am talking about. For complex reaction, order is given by the slowest step, and molecularity of the slowest step is same as the order of overall reaction. Both will be the same. That step only, slowest step is responsible. Then molecularity of the slowest step is same as the order of several, you can say order of overall reaction. This I have discussed order and molecularity. Now I am going to derive, you can say, integrated rate equations. Integrated. I really now already told you that there are 3 rates you can tell. First is the first rate I told you, that is the average rate. Second rate, that is the instantaneous rate, by graph only you can draw. Third rate is differential rate, and fourth one is also there, integrated rate. Then you can tell 4 type of rate. First, average rate. Second, instantaneous, at any particular second, any particular time, that you can draw only by graph. And third one, differential, like minus dx upon dt. D is means differential. And fourth one is integrated rate of reaction. Then now I am going to discuss this rate. Okay. Then now first I will discuss, that is the zero order reaction. It is very, very important zero order reaction. Okay. By the name you might be thinking zero order means this reaction does not depend on reactant. Correct? Order means which term, which reactant must be, you can say, have value, has important. Correct? Because you are writing rate is equal to minus is equal to K into molecular concentration of reactant. Correct? But here molecular concentration has no value, zero value upside, overall zero value. Suppose two are there, A and B, then power A power 0, B power 0. Overall is the 0. It means what? That this rate of reaction does not depend on you can say reactant. Initial concentration, you can tell, does not depend on initial concentration. Then here how will you derive the expression? That I am going to tell. Okay. Here you should understand R means reactant, P means product. Means R will give product. R arrow sign, P you can write. Means reactant gives the product. Then rate will be what? Rate will be minus dr upon dt. Minus dr upon dt. That is equal to K into R, molar concentration of R, but power is 0. Power you can write 0. Means rate is equal to means minus dr upon dt. R is capital, molar concentration of R, in bracket you can write D in bracket capital R, that is called molar concentration of R, divided by dt, a small d, both up and down, d means differential. Then dr upon dt, minus dr upon dt is equal to K into R, power is 0. For the reaction R is giving to product, then here R is the reactant, and R has R power is 0. Correct? Now this is the first step, and now for second step I am telling you, as any quantity raised to power 0 is unity. Power 0 means what? That thing will be unity. As any quantity raised to power 0 is unity. Hence you can write as a second step, that is equal to dr up minus dr upon dt is equal to K into 1, that is equal to K only. Then dr upon dt is equal to K, minus dr upon dt is equal to K. Then both you can say these things, dr upon dt is equal to K. Then what will be the dr? Cross multiplication you can do. Minus dr is equal to K into dt, cross multiplication. Minus dr upon dt is equal to K. Then what is the value of dr? Minus dr. Then minus dr is equal to minus K dt. Minus K dt. Correct? Now you have to integrate it. Integration you are doing. It is a d, differentiation. Dr is equal to minus K dt. Then now you have to do integration of this. Then what you will get? You are integrating. Then if you integrate, then d term will go. Then only R will remain. Left side only R will remain. Dr was there, you have integrated, then it became R, means molar concentration of R. That is on right side, that was K into dt, then K is the constant, then no integration for constant. Okay, and for dt, d will go, only t will remain. Then K into dt means Kt only, plus integration constant. You know these things in mathematics already you have studied, that here it become, after integration, it became R is equal to Kt plus I. I is the integration constant. Okay, this is the important step. Then now this important step, suppose this is the third step. Okay, then now you have to find the value of integration constant I. Then it is very easy to find the integration of I and this value of integration constant I. Then for that, what you have to do, that this constant of integration or integration constant, anything you can tell, constant of integration. You want to know the value of constant of integration I. Then for that, you consider that at t0, when means the reaction has started, that is the t is equal to 0 time. You can tell 0 time, t is equal to 0. Then if time means in the beginning, when t is equal to 0, the concentration of the reactant, concentration of the reactant will be what? Concentration of the reactant R, you can tell, concentration of the reactant R will be equal to R power 0. R, molar concentration of R, power 0. Correct? Then at t is equal to 0, concentration is R power you write, down you can 0 write, no problem. R 0 you can write. Okay, down you can write 0 as script, R 0. That is the 0 means in the initial. R 0 means concentration of reactant in the beginning, R 0. And this is also called initial concentration of the reactant. Then now you can see this value in the place of R, you write R0. In third step, you have written in that you want to know value of I, constant of integration. For that, in the place of R, you write R0, and in the place of T, you write 0. Then what will happen? Actually, third step reaction is R is equal to minus Kt plus I. I value want to know. Then R became R0 when T was 0. That is equal to K into T. Then T is equal to 0. Then 0 into K, that is equal to 0. Then what you will get? Plus I was there. It means I is equal to R0. I is equal to R0. Then now in the place of I, you write R0 in the third step. In that third step, I value now you got R0. Then now equation became R is equal to minus Kt plus R0. Correct? All things are same. Equation third. R is equal to minus Kt plus I. But I is equal to, now you calculated R0. Then now next step will become, now R you also got, R0 is also there. Left side R and right side in the place of I, R0 is there. Then both R you bring one side. Means now minus Kt was there, that you bring it left side, it will become plus Kt. And right side R0 was there and R was left side, that you bring right side. Then what you will get in fourth step? Kt is equal to R0 minus R. R0 minus R means molar concentration of R0 minus molar concentration R. Okay. Whenever I am telling about the molar concentration, you think bracket, big bracket. Okay. Then now you got Kt is equal to R0 minus R. Okay. This you got. Then after that KT is equal to, now you got R0 minus R. Then now you can get the value of K value. K value you can get KT is equal to R0 minus R. Then what is the K value? Then R0 minus R divided by T means time. Very easy. Very easy. Now you got the value K is equal to R0 minus R divided by T. Okay. Now actually you can plot, you can draw a plot. That plot, that is the concentration of R divided by, or you can say this plot you have to draw concentration versus time. Concentration versus time. Correct? You will get a straight line. Or you can tell, if you will compare what you got now, this you got now equation KT is equal to, or you can tell you got KT is equal to, you got KT is equal to R minus R0 minus R, that you got. Then if you compare this is from the equation y is equal to mx plus c, a straight line equation, y is equal to mx plus c. Then if you will compare both, then that time you have to write R is equal to KT plus R0 that time. Then y is equal to mx plus c, you can compare. Then you can draw a this plot. Then plot will be, you can say concentration versus time. Then what you will get? Then comparing with equation of a straight line y is equal to mx plus c, if we plot R against T, R means concentration against T, we will get a straight line with slope. Slope will be value of K. Slope will give the value of K. Okay, or slope is equal to minus K you will get. And slope, you know, slope is equal to tan theta. Tan theta is perpendicular by base. Then perpendicular means this vertical line where a straight line will cut. It will cut to the y axis, vertical line. Then where it is cutting, that is actually that from 0 to that point, that is called intercept. That is called intercept. Then that this slope will give the value of minus k. Okay, and intercept equal to R0. Intercept will give the value of R0 because you have drawn R versus time. Then where this straight line will cut upside, that 0 to that point, that will be the R0 value, that is called intercept. Then now intercept value also you are knowing, slope also you are knowing. Slope means tan theta is equal to perpendicular divided by base. Okay, that is called slope. Then that value will be equal to minus k. Okay, further now k value you are knowing. K value you are knowing. Then equation was simple. KT is equal to R0 minus R. Then K is equal to R0 minus R divided by time. Then now K value you are knowing. Then actually your intention was to know the K value. Then now you are knowing the K value. Okay, K value means rate constant, and rate constant will determine the rate of the reaction. Only condition is that that time that is for unit concentration. Unit concentration. Concentration you have to consider unit in unit time. Then that time rate become equal to K. Rate becomes equal to K when molar concentration is unity and time is also unity. Okay. Then now you got the value of K. Then now I am giving some examples of zero order reaction. Zero order reactions are relatively uncommon. It is not common, but they occur under special conditions. Some enzyme catalyzed reaction and reaction which occurs on metal surface are a few examples of zero order reaction. Generally, enzyme catalyzed reaction and reaction which occurs on metal surface are only few examples of zero order reaction. Example I am telling you, decomposition of gaseous ammonia on hot platinum surface. Platinum metal is there, surface is there. On that, suppose ammonia gas is there, then it will decompose. NH3 gas, it will decompose and it will give nitrogen and hydrogen gas. Then this reaction is the example of zero order reaction. And this also high pressure is required here. Not simply you will keep these things ammonia gas on platinum surface and it will react. No, high pressure is required. Then 2NH3 at high pressure and on the surface of platinum, PT, platinum catalyst, it will decompose and it will give N2 plus 3H2. 2NH3 will give N2 plus 3H2. Condition applies that pressure should be high. Temperature should be also high. Okay. Then in the presence of platinum, reaction will take place, means decomposition will take place. Okay. Now rate, for this reaction rate you can write like this. Rate is equal to K, molar concentration of ammonia power 0. Then power 0 means 1, then K into 1, that is equal to K. Hence rate is equal to K. Then here no concentration term is there. No concentration term. Then in this reaction, platinum metal acts as a catalyst. At high pressure, the metal surface gets saturated with gas molecules. Why high pressure? That I am telling you. At high pressure, the metal surface gets saturated with gas molecules. So a further change in a reaction condition is unable to alter the amount of ammonia on the surface of catalyst, making rate of reaction independent of the concentration. Because pressure is high, then that is sufficient for the reaction. Other things are not required. Pressure is required. Then all molecules will be fully saturated. They will react themselves. Okay. Then here means other change of concentration, that is not required. Does not depend upon the initial concentration. Okay, but substance is required. Substance is required, concentration is not required. But high pressure is required. Then we can conclude that thermal decomposition of HI, actually another example I want to give you. After that conclusion we can draw. That this thermal decomposition of HI, hydrogen iodide on gold surface is another example of zero order reaction. Correct? It is not depending on the initial concentration. Concentration of the reactant, it does not depend. Always remember, question is asked, many times question is asked in all examination. Okay. Then this I told you about the distance, zero order expression. You remember K is equal to R0 minus R divided by time, and final, that is the K is equal to, you can write that rate is equal to K only. Rate is equal to K, or K into NH3 power 0. Power 0, 0 means 1, and K into 1, that is equal to K. This I have told you. Now another expression I am going to derive. Okay, that is the first order reaction. First order reaction. Then see, now by the name only you can understand first order means now it will depend upon the one concentration. Reactant will be there, maybe more than one, but at least one concentration is required. Okay, means concentration of reactant. Suppose two reactants are there, then at least any one reactant concentration is responsible. Two reactants are there, any one concentration of reactant is responsible. Okay. Then you can write the, keeping in mind this, you can write the expression. Okay. Then again same equation you consider in general way. R is converting to P, means reactant is giving to product. Okay, capital R means reactant, it is giving the product P. Then for this reaction again rate same way will write. Actually all things are same, but here little long will be there. Quickly you can understand, not a problem. Then rate is equal to minus dr divided by dt, that is equal to kr, that is equal to k into r. R is the reactant, means concentration of reactant. Here again you can write same way, minus dr upon dt is equal to k into molar concentration of R. Again you can do cross multiplication, then you will get minus dr is equal to what? Is equal to k into dt. Here I am telling you, again you listen, rate is equal to minus dr upon dt, that is equal to kr, Then now both R you bring together, okay, and cross multiplication you do. Then now in the place of dr, in the place of dt, R will come, and in the place of R, dt will go. Cross multiplication. Then now it will come minus dr upon R. That is equal to k into dt, because dt went to the place of R and R came in the place of dt. Then now it became minus dr upon R, that is equal to minus kt, minus k into dt. Minus you have taken to the right side. Okay, any side you can write, but now we write right side, minus sign. Then this is the starting point. You should be careful. Both R should you bring same side. It will come dr upon R, and right side will become k into dt. Now what you have to do, this you consider as the second step, dr upon R, that is equal to minus k into dt. This you consider as a second step. Now after that you are going to change. Third step, now real things you are doing. But it is mathematics. Now just to integrate it, you should take integration. Zero order you have taken integration, here also you take integration. Only the thing is that both are in the are together. Okay. Then now if you will do integration, then what will happen? Integration of dr upon r, you know, it will give ln r. Okay. Integrating this equation, then dr upon r, integration of dr upon r is well known, it will give ln r. And right side, this is the left side, right side, then right side k dt was there, k into dt, then k is equal to constant, k is equal to constant, then there is no integration for constant, and dt is there, dt, then now integration of dt, it will give only t, dt is there, d will go, only t will remain, means that is now it became k minus kt, k is as it is, and dt became t plus integration constant plus I means integration constant, correct. Then now equation became ln r, ln molar concentration of r is equal to minus kt plus I. This you consider as a third equation, third. Now same things you have to do. You have to find out the value of I, integration constant or constant of integration. What will be the value? Then here any time when you want to know the value of integration constant, then you should start with 0, means at 0 time. Okay, at 0 time what was the concentration? Then when t is equal to 0, kt is there, kt is there, ln r is, that is equal to minus kt plus I. You want to know the value of I, then here when t is equal to 0, then r will become r0, like previously for 0 order, that time then same way r will become r0. Then now put the value in the place of r, you write r0, and in the place of t you write 0. In third equation t is equal to 0 and r is equal to, in the place of r now you write r0. Then now after that equation will become how much? ln r0, ln r0 is equal to I. Okay, means you got the value of I because t is equal to 0. T is equal to 0, then k into minus kt was there, the minus k into 0, that is equal to 0. Okay, then you got the value 0, then ln r0 is equal to I only, hence you got the value of I. Then in fourth equation now you write the value of I, then now you got the value ln r, that is equal to kt, minus kt was there, write minus kt plus ln r, ln r0, in the place of r you write r0 because you got the value of I. Then now equation third, in the equation of third you kept the value, now you got the fourth equation, ln r molar concentration of r, means in bracket you have to write that is equal to minus kt plus ln molar concentration of r0. Okay, r0 means initial concentration. Then this is the fourth step. Then now actually you are very close to the final. Now again both r you can bring together, then what you will get? Minus kt is equal to what? 0 plus 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 ln R minus ln R0. You can write. Here, this is your wish. What you will write by, because minus KT is there. Minus KT is there. Then minus KT is in left side. You bring right side. Then it will become plus KT. And left side ln R is there. That you bring right side. Then both R will become right side. Then plus ln R. Now this side it will become minus ln R. Then you will get KT is equal to ln R0 minus ln R. Correct? Or I told you, as per your base, if you want to keep as a minus KT only, then you bring right side ln R0 to the left side. That also you can do. Then you will get ln R minus ln R0 minus ln R0, that is equal to minus KT. Then anyway you can write. Better you actually finally you have to find the value of K. Finally you have to find the value of K. Okay. Then better you KT you bring minus KT, that you bring to the left side. Then it will become KT, and ln R that you bring right side. Then ln R minus ln R0 minus ln R you will get. Means KT is equal to ln R0 minus ln R. ln is natural logarithm. Already many times I told in the beginning only. ln is equal to natural logarithm. Then now you got the value of KT is equal to ln R0 minus ln R. Then what is the value of K? Then very easily, then K is equal to, now this ln R0 minus ln R divided by T. Then now you got the value of K. But here one thing you have to do. KT is equal to ln R minus ln R. You have written KT is equal to ln R 0 minus ln R. Correct? You have written. Now here you have to apply log formula, because log x minus log y is equal to log x upon y. Log x, log base 10, x minus log base 10 y, that is equal to log base 10 x upon y. This formula you have to use. In the place of ln R0 minus ln R, you can write same formula. You can utilize ln R0 upon R. ln R0 upon R. Correct? The same, by using the same formula. ln R0 upside, R down. And this is equal to KT. KT is equal to, now you can write ln R0 upon R. Then what is the value of K? Then this time will go right side, 1 upon T. Then now it became 1 upon T ln R0 upon R. Because how you can tell, if you want to write in the term of log, now you have written in the term of ln, natural logarithm. Then very easy, K is equal to 1 upon T into ln R0 upon R. But if you want to write in the form of log, then you have to multiply by 2.303. Correct? ln, if you want to convert in log, then you have to multiply by 2.303. Then now your K value will become, K is equal to 2.303 divided by time, log base 10 molar concentration of R0 divided by molar concentration of R. This is the final result. Okay, this is the final result. Then now again, this is actually main result, but now if temperature will change from T1 to T2, then what we will do? Now temperature, this is a general expression. K is equal to 1 upon T ln molar concentration of R divided by R0, or you can tell this if you want to convert into log, you can tell K is equal to 2.303 divided by T log R divided by R0 divided by R, correct? But if temperature is changing, then what will you do? Main things you have done, equation you have derived, but now modification. At time T, at time T1, suppose time is changing from T1 to T2, then concentration will change, correct? Then that situation I am talking about. At time T1, what will be the, can say, main equation, what we are doing, you have derived, then that is the ln R1, that is means I am talking about now fourth equation. After we have put the value of I, that state, after putting the value, that is the fourth step. Then here ln R1 you can write. L1, time is changing, the concentration will change. In the beginning, now consider it was 1 and not this thing. After some times, now it is become T you can consider after some time. Okay, concentration became T, RT, like that. And in the beginning, R0 only. Then you can write ln RT, ln molar concentration of R, and T you can write outside after bracket, big bracket down, just to write RT. That is equal to minus KT plus ln molar concentration R0. Same way, R you write in bracket, and outside the bracket down a small 0 you can write. Then like that way, at a time, this is actually at a time T1, okay, T1. Then you have written like this, in the place of T you have written T1, and concentration you have written at time T, concentration was RT, okay, RT, or 1 also you can write, no problem. T1, any time concentration, in the beginning concentration, when temperature was T1, concentration was R1, like that way you can write. R1 only 1 you write, it is good, okay. And at time T2, then in the same formula, fourth step, now KT2 it will come. Here two equation you are getting, one in term of T1, other in term of T2. Then ln R1, that is equal to K minus KT1 plus ln R0. Same way, if can say time is 2, at a temperature 2, what will happen? At time 2, not temperature, at time 2, that will be same way, ln R2, that is equal to minus KT2 plus ln R0. ln R0 will be common in both equation here. Then now just you have minus it, deduct it from the, suppose equation A, equation B is there, A minus B, then you will get ln R1 minus ln R2, that is equal to minus KT1 and minus, then in bracket minus KT2 you can write, because you are deducting. Then minus KT1 minus, in bracket again minus KT2, then minus plus then plus you write first, then minus term you write, then it will become KT2 minus KT1, because minus minus become plus, then plus sign you write first, it is easy, good. Then it will come KT2 minus KT1, and K you can take as a constant, common you can take, common. Then in bracket it will become T2 minus T1, means K outside, common you have taken, and bracket now it become T2 minus T1. And the left side ln R1 minus ln R2. Then this now you are knowing by using the formula log x minus log y is equal to log x upon y. Using that formula, now ln R1 minus ln R2, that you can write ln R1 divided by R2, ln R1 divided by R2, that is the left side, and right side is equal to K inside bracket T2 minus T1. That is the another form of reaction, that is the same derivation you have done, but for the two temperature, for the two times, not temperature, for the two times, T1 and T2 times, and you have deducted it. Then you got new form, another form of equation at a different time. Then now you got this, you can tell as a final, after the final already you have done. Now this is again important reaction, that you can give any other you can say equation number, maybe 6. Okay, then this you got important relation, that ln R upon R0 is equal to K and inside the bracket K is outside and in bracket T2 minus T1. Then K value easily you can determine. K is equal to what? Just this you have to divide by T2 minus T1. Then you will get K is equal to 1 upon T2 minus T1 ln R1 divided by R2. Same things you got. What you got in final expression that time, K is equal to 1 upon T ln R0 upon R. Same things here you got. In the place of T, you have written T2 minus T1. Simple. And because you have written that plus K2 first and then minus, that's why now this will reverse. Ln, that time it was R0 divided by R. Now it will be reverse. R upon R0 means R means here you are talking about R1. Okay, R1 divided by R2. There R0 was above and down was R. Then here means for your technique I am telling you to remember, 0 and R was there in the main derivation. 0 was up, R was down. Then now here also 0 means initial. Then here R1 is up. Then R1 means also you can tell initial. R1 means initial and R2 at any other time. Means always initial you are keeping upside. This is the technique to remember. Okay, upside always initial. Then here it became K is equal to 1 divided by T2 minus T1 ln R1 divided by R2. And in the main it was K is equal to 1 upon T ln R0 divided by R. R means concentration at any time, molar concentration of R at any time. Then this is the main equation you have derived, K value. Then only by cross multiplication K and T, any time you want to know the value for T, then do cross multiplication. correct? If you want to K, then okay. Generally, actually both are, you need both in the term of K also, in term of time also. Then it is very easy. In the place of K you write T, in the place of T you write K. That's enough. All things will be the same. K is equal to 1 upon T ln R0 upon R. Then what is the T? T is equal to, then just K will come down and T will go in the place of K. T is equal to, it will become T is equal to 1 upon K ln R0 upon R. Very easy. Then this I have discussed you and derived you the first order reaction. Okay. Now this formula you can write in various way. As for example, ln R upon R0, that is equal to minus KT. I am not doing anything. Only you can do left to, you can bring left to right, right to left. No change. By doing that way, you will get ln R. Only rearrangement you are doing, nothing new. Main thing I told you, as per your requirement, you can make change. Then I am telling you, in numerical time, solving times, you need this form, means ln R divided by R0 is equal to minus KT. One form, and another form also you can take ln R upon R0, that is equal to minus KT. If you will take anti-log, then what will happen? Initially this relation is used, ln R upon R0, that is equal to minus KT. Already you have done these things. Then if you will take anti-log, this same formula, if you will take anti-log, then it will become R is equal to R0 E minus KT, exponential power minus KT. That you know. ln is there, anti-log you are taking. Then what will become? ln R upon R0, that is equal to minus KT, correct? Then what will be the value of R upon R0? ln will convert into E. It will become E minus KT, E power small e, exponential power minus KT. Then R upon R0 is equal to E power minus KT. Then what will be the value of R? Then just to do cross multiplication, R0 will go right side, then left side R, and right is equal to right side R0 into E power minus KT. This is again very important relation. Okay. Then like that way, this you have done, only rearrangement you have done, different way you are talking. Then I have discussed, you can say, derivation. Now I am stopping only here. Next class again I will discuss other things. Thank you.